Hey guys, so for this video we're going to do a pretty simple concept that it can get convoluted, is calculating pH and also calculating the H+ concentration in solutions. So this is for Chem 101 for chapter 7, but whoever else is interested. So first note is, remember, in a solution, H3O plus concentration is equal to H+ concentration, right? Another thing to note is that the brackets mean that it's in molarity. This is in molarity. And remember, molarity is moles per liter, right? Moles per liter, and it's represented with a capital M. So, what is the pH of a solution with an H+ concentration of 2.7 times 10 to the 8 molarity? So, things to know about pH. pH is equal to the negative log of the concentration of the H+ ions, right? So if pH is equal to negative log of the concentration of the H+ ions. pH is actually a unitless number. That's good to note. So it should be unitless. So there shouldn't be any, it's not molarity, it's not grams, it's just a unitless number. So how do I find this? This one's a simple plug and chug because I'm solving for pH. Negative log, and then parentheses, I have my concentration of H+ in molarity. I do. That's what the problem has. So for this problem, pH is going to equal negative log of 2.7, I meant to put negative 8, 2.7 times 10 to the negative 8, and it's in molarity already, so I don't really need to type that in. So let me grab my good calculator, and I'll show you how to type this in. So I'm going to need to have negative. So negative is this sign, right? Make sure you don't use the minus sign. Make sure you use the negative sign. So negative log, so it's just going to be the log, which is hanging out right there. And then it's 2.7 times 10 to the negative 8. So 2.7. And then on my calculator, it actually has this handy dandy little times 10 to the button, times 10 to the negative 8. Make sure you close your parentheses. Hit enter. I get 7.56. So that is the answer. The other way around, we're going to have to play with our calculators a little bit more. So this one says, well, what if I give you the H+ concentration, the hydrogen ion concentration, and I need the pH? So we're going to use that equation that we're given. pH is equal to negative log of concentration of H+, right? Well, I'm given pH. I need to solve for H+. So 12.4 is equal to negative log of my H+ concentration. Oops, I used a bracket and doesn't matter. This is scratch work. So how do I solve for the H+ concentration? So I'm going to have to move the negative over here by multiplying both sides by negative. So negative 12.4 equals log of H+. Okay, we're almost there. Now, to get rid of the log, what do you use? In your calculator, you're going to see, if you hit shift log, you're going to have 10 to the times 10 to the. This is anti-log. So essentially, I'm going to write the rest over here. I'm going to have to write anti-log. I've seen this a few times. Anti-log negative 12.4 equals my concentration of H+, right? So second log, negative 12.4. How do I type that in my calculator? Second, oops, sorry, clear. Second log, so 10 to the negative 12.4, and the parentheses. That's 3.98 times 10 to the negative 13. Should it be a tiny number? Yes, 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 right? So 3.98 times 10 to the negative 13, and the units is molarity. So you could write anti-log, or you could say, right over here, 10 to the power of negative 12.4 equals the concentration of H+. So this is us putting on our, what is it? I can't even remember. Us putting on our algebra hats and remembering how to do this. So go ahead and make sure that you can go both ways. I can give you a pH, and you can give me the concentration of H+, or I can give you a concentration of H+ and you do the pH. Well, one's a little bit more direct than the other, but they should be just as easy as they should, be equally attainable on an exam. So the key is making sure that you have a calculator that you know how to work. You know how to do exponents. You know how to do the negative, and you know how to do the second log, the 10 to the power of. So practice, and make sure you can do this at home.